Hello everyone, I am Nipun Nuswatta, a student who is following an MSc degree in Advanced Software Engineering at University of Westminster. Welcome to my research presentation on AI-driven suicide early prediction system from social media. So initially, let's discuss about the identified problem. So by doing a thorough literature review, I have identified few problems related to this suicide early prediction system based on social media. So in this case, I took Facebook as the social media. So the identified issues are the optimization of machine learning algorithms for early detection of suicidal ideation within social media posts. So in here, I am going to identify the suicidal ideation of the comments that are there in Facebook posts. Then they identified other research problem is effective utilization of natural language processing techniques for extracting linguistic markers indicative of suicidal intent from textual data. Then the other identified research problem is integration of convolutional neural networks to enhance feature extraction from textual and visual content in suicide detection. Furthermore, by doing series of interviews and by conducting a literature survey, I have identified there are some strategies for addressing privacy concerns, obtaining user permissions, and mitigating the risk of stigmatization while maintaining high prediction accuracy in identifying signs of suicidal ideation. Right, so let's move to the proposed solution section for the identified research problems. The problem addressed in this study involves the development and the deployment of AI-driven system leveraging machine learning, natural language processing, and convolutional neural networks to detect early signs of suicidal ideation within the social media posts. Then, the challenge lies on formulating algorithms that effectively analyze textual and behavioral patterns exhibited by users on platforms like Facebook. Furthermore, this entails the utilization of NLP techniques to extract the linguistic markers indicative of suicidal intent and the integration of CNN for enhanced feature extraction from textual and visual content. Additionally, the problem necessitates addressing privacy concerns, obtaining user permissions, and mitigating the risk of stigmatization while ensuring the system maintains a high level of accuracy in predicting and identifying warning indications of suicidal ideation. Right, so this is the proposed system architecture. So before moving to this system architecture, I should mention there are two types of datasets. First of all, I am using an existing Kaggle dataset in order to work with for this system. Then apart from that, I have a manually collected dataset from Facebook social media posts. So based on the existing datasets, initially I am doing a text pre-processing in order to have a clear and a clean dataset to do the sentiment analysis. So after going through the sentiment analysis process, mainly I am identifying what is the test dataset and what is the trained dataset. Then using this trained dataset in order to do the model training part. So as the model in here, I am using a BERT model to do the model training part. The reason to use BERT model in here, since it is leveraging so many benefits when we are doing a text model training. The main benefit that I am seeing with BERT model is pre-trained on large corpora of text using the unsupervised learning, which allows it to capture rich contextual information from the input text. And apart from that, since this is a bidirectional context, unlike the previous models that process text in one direction, BERT captures bidirectional context by using a transformer architecture with attention mechanism. This enables it to understand the meaning of the words in the context of the entire sentence, leading to better performance on tasks requiring understand the context. And apart from that, BERT can be applied to wide range of natural language processing tasks, including text classification, named entity recognition, question answering, sentiment analysis, and more. At the end of this train model, then we are getting whether that provided text is suicide or non-suicide. So there is a temporary database to hold these predicted results. So in this process, for a given sentence, initially it will identify what is the sentiment of that text or else that provided social media comment. Then by going through this trained model, it will identify whether that provided text is having a suicidal or a non-suicidal ideation. Furthermore, if the identified text is a suicidal related text, then it will identify the level of that suicidal comment. Having series of conversations and interviews with different types of psychologists, I have identified 3 levels of suicidal ideation. So in here, after identified this suicidal related comment, it will show you the level of that particular comment. When it comes to the real world application scenario, after a user enter a comment, then he or she will be able to get an output whether that provided text is a suicidal one or else it's a non-suicidal one. Other than that, if it is a suicidal one, then he or she will be able to see the level of that particular comment. Right, let's move to the demonstration part of the model. So in this scenario, initially I am going to talk about the sentiment analysis for the suicide detection. So after importing the necessary libraries, I am importing my dataset. Then I am following some text visualization parts in here. Then in the data preprocess part, I am going to find the null values. Then I am taking the class count as well. So in here you can see in my dataset, I am having main 3 columns, the text comment and the class. So in here class will indicate whether that comment is suicide or non-suicide. So when creating the dataset, I have identified all these provided comments are suicide or non-suicide as the pre-trained model. Then there is a age column as well. Then I am doing a quick EDA in here. So I am going to plot the data visualization in my dataset. So in here you can see a bar chart. So in here we can see suicide and non-suicide counts by age ranges. Then at the end of this sentiment analysis process, I am using the transformers model in order to do the sentiment analysis. So after doing the sentiment analysis through the pipeline, I am going to send a comment in order to identify whether that provided comment is having a negative or a positive sentiment. So when I am providing a comment in here and I am getting the sentiment of that particular comment. So in here we are getting the sentiment as negative and also there is a high value score as well. Then let's move to the second model that I have built in order to do the suicide detection using the BERT model. So after doing the initials like importing the libraries, importing the dataset, I am going to do the data preprocessing part in here. So in here as the first task, by using the lambda function, I am going to divide the 2 parts of the class. So mainly in the class column we are having suicide and the non-suicide labels. So in this function I am assigning 1 for the suicide and if it is not 0 for the non-suicide as well. Then I am splitting the dataset into train and test. Then I am importing the BERT model in here. So in here I am using BERT preprocess and the BERT encoder. Then there is a define embedding function in order to connect this entire BERT model with the client application. Then when it comes to the model training part, so in here you can see I am executing the model architecture, the build model architecture in here. So I am having few layers in here, and apart from that we can see the model summary in here as well. So since there are multiple layers in this BERT model, we can see the interaction between each and every layer from the beginning and to the output or this dense layer. Then the next important part is, so in here I am executing the matrices that I have built to this module. So in here we can see there is, I am going to take the accuracy level, prediction and the recall level. As the final step of the model training part, I am sending 25 epochs in order to get a high accuracy level and a high recall level. So in here, depending on this dataset, I am sending 25 epochs and I am getting a recall level as 0.67 and also accuracy level as 0.73. Then after that, I am doing a model evaluation in here. Then we can see the accuracy, precision and the recall level of each and of this model. Then I am going to generate the confusion matrix based on this model. In here, I am going to plot the confusion matrix as well. Then we can see the classification report in here. Then finally, I am doing the model interference part. So again, I am going to provide a comment in order to identify whether this provided comment is having a suicidal ideation or else it's an unsuicidal ideation comment. So let's provide a comment and I'm going to execute it, and we can see the prediction of this model as well. Then finally, we can see the outcome of this particular comment. So in here, I am getting the predicted output as suicide for this provided comment. Okay, so that's about the model training and the demonstration part. So let's discuss about the further improvements of this project. So in here, I need to enhance the dataset by scaling up the data collection efforts, encompassing diverse demographics and social media platforms to improve model generalization and robustness. So for the moment, as I mentioned earlier, I am dealing with two datasets in this project. In the existing dataset, there are around 350,000 records as the social media comments. So when using that particular dataset for this module, I am getting a high accuracy level around 0.98 and also high recall level around 0.90. The next further improvement is implementing language translation functionality to extend the system's reach and effectiveness in detecting suicidal ideation across multiple languages and multiple cultures, and furthermore on refining the suicidal level prediction accuracy by fine-tuning model parameters, exploring advanced feature engineering techniques, and integrating additional data sources to enhance the system's predictive capabilities and reliability. So that's all about this demonstration. Thank you very much.